So will admit that it was very daunting to be told that, hey, the workshop that you were pitching is maybe like an ancillary thing, is going to be part of the main conference. Oh, and also it's the same day as your talk. So you can imagine that it did a huge amount of prep for the workshop. Not at all. I really wanted to do this, I think, in large part because I feel like I've been getting a lot of different questions from folks in Discord and even in person about how do I migrate to WarpDrive. I felt like there was a lot of misconceptions around it, actually. So a very short poll. Do you currently use Ember data? Amazing. All right. Do you use WarpDrive? Almost all of you are wrong. The answer is if you use Ember data, you use WarpDrive. It is just a rebrand. So I keep hearing people being like, I'm terrified of the migration to WarpDrive. It's like, it seems like a really big change. It's the same library. So with that in mind, I actually wouldn't mind asking a couple of questions. One, what is something that is currently holding you back from using WarpDrive? And if we have a mic, that'd be good for this. Yeah. Sorry, Joshka. I think over here we have a question. Or you didn't? Yeah, the question is, what holds you back from using WarpDrive? Or what time? Anybody else? Fat models?
Yeah, I mean, I think some of it has been cleared up by your talk earlier today. For me,
that's great.
the millions of packages that you just you join, like you go to the README of WarpDrive and there's like the big list of packages compatibility, and I'm just like, whoa, okay.
I do think that that's been a little daunting to folks, like the eject from the Ember data meta package, as I call it.
Yeah.
It's like, oh, whoa, okay, I went from knowing about one thing to knowing about 60 things in 2 seconds. This is not good. I guess the corollary question to this then is like, what does it actually mean to you to migrate to WarpDrive?
I'll stay on that side.
Yeah.
And there was a question in the chat, by the way, as well.
If someone wants to read that to me, that'd be great.
We will.
Yeah, hi again. Yeah, I guess for me to migrate to WarpDrive, I would have to be confident I'm using schema records. Am I saying that right? Or records?
Reactive resources, the official branding, but yes, originally schema records.
So I expect not to have model classes, like a folder of model classes anymore that are just, classes like we used to, like extend model, whatever, and just, I guess, have a bunch of records, but I don't really understand what a record is and how it works. I mean, I also haven't really invested time into looking into it, I have to admit. So yeah, but that would be moving to WarpDrive for me, I think.
Cool. Anybody else?
It's a specific question for one of the apps I would port. It's an app that's currently on Orbit, and I don't know how to model state forking in the way WarpDrive would think about it, like fork and merge of state.
Yeah, I think it's definitely a dinner table conversation, but the high level view is you don't. So we did spec out forking APIs in WarpDrive. We never actually shipped an implementation for it. Mostly because as we got deeper into what Polaris mode meant and what the future features beyond Polaris mode that we haven't even really talked about much yet meant, we realized that forking didn't fit. Instead, we're going to keep the cache having 2 versions of the state, a dirty version and a clean version, but do a better job of surfacing to you which one you're using.
Yeah, and that's the class of answer I'm looking for. Like, it doesn't have to be that implementation, but it's just like, what is the mental model was my question. Yeah, and that's the answer.
So
There are questions in the stream.
Yes.
One of them is a tongue-in-cheek question a bit, I think. Fragment support.
Fragment support.
Fragment support.
That's the question.
It is a question, right? So the awesome thing is that we merged the model fragment support PR like 2 days ago. And so it's in Canary. I will show you about what that looks like later today. Unfortunately, I didn't have the time to type up a model fragments specific example, but we've been working on a code mod. So I'm going to walk you through more of the manual process today for migration, but we are working on a code mod. I also kind of dangerously hit merge on the code mod today. It's in Canary. If you want to try it, I have zero guarantees that it works. It seemed to be working on Auditboard's code base, but no, we haven't actually for real tried it. We're using the audit code base to kind of test it out. That code mod, we're going to build model fragments into that code mod. It should take any app on 4.6 with model fragments or 4.12 all the way to latest in one go. So even if you are stuck in 4.x because of things like the array-like deprecation, we think we will be able to take you in one go. Yeah.
The other question here is documentation around defining schemas.
So I think this is an area where there is kind of two answers. One is we need to finish the guides portion of the individual schemas and fields and what all you can use them for. I had hoped to get that done by Emberfest. I think I just ran out of time. I shipped so many docs before Emberfest to try to get ready for this, and I ran out of time on those. The API docs are there, and I think they're better than you realize. If you were to look at it in the published documentation, it doesn't seem very useful. And that's because the default for typedoc when it comes to documenting an interface is to kind of like pull every single field apart and flatten it. And you can't tell when something's like a nested thing versus a top level thing in an object. So we need to ship a fix to basically the pipeline for publishing that makes the documentation for interfaces a little cleaner in the web-based documentation. But if you go into the source code, like there's a link from that doc into the source code for where that type is documented in the source code, that will actually probably be a really fast way for you to discover what's possible because that documentation actually is there. It's pretty good. The TypeScripts, the types are pretty good too. Any other questions before we kind of dive in?
Yeah, it's maybe not a fully formed question, but I am not mega confident in the way we use Ember data currently in our code base, as in, do feel we are one of those companies that use a lot of like in-component data loading, and we've tried a bunch of, let's say, less than optimal patterns. I've tried to follow through the years, like now we use tracked function a lot, but we're not supposed to be using that for that kind of purpose. And there's a lot of that kind of stuff in there, and I'm a bit worried that maybe WarpDrive is more strict, or let's say the new WarpDrive is more strict in that area, and things would be hard to migrate.
I think we are simultaneously less strict and more opinionated.
Okay.
So promises are still promises. So anything that you're doing with async that's working for you today will continue to work. All right, as long as it's still a promise, it continues to work. But we do have ways that we think you should be working with promises now. So if you look at WarpDrive Ember, it offers an await component and it offers get promise state. Those are for working with generic promises, including anything from like the more legacy APIs like store.findRecord or an async relationship. Then if it is something that's a little bit newer and you're using store.request, then the intent is that you should use get request state and the request component and those APIs for async. In terms of where do I do my data loading? I think I used to always say do it in the route. I still think that you probably should do it in the route. But that's not actually, like, I'm going to say that, and I'm going to immediately walk it back because that's not actually the story that we're shipping. The story that we're shipping is you can put the request component anywhere and load wherever you need to. The idea that it's an asynchronous boundary inside of which the data is there for you, outside of which, who knows? At any depth. What's amazing about builders is as a compositional primitive, it gives you access to the same request everywhere that you call it. So you load data in your component. Later, you realize, you know what, from an optimization perspective, I really wanted to go ahead and kick this request off in my route, maybe even wait on it. You use the same builder to build the same request in your route. You don't have to do any prop drilling. It's just going to dedupe itself. And there's several layers in between that we haven't built yet. Like I see in the future WarpDrive actually offering a router, and I see it offering a provider component that handles several layers in between where the request component will sit in your app and what the routes model hook is today. I don't think the story is fully built out, and that's probably where some of the confusion ends up coming from for folks, because I still say, hey, you should maybe do stuff in the route. And then I also say, but yeah, I use the request component wherever you want to. Like, that's how those things are going to come together.
Yeah, for me, it's also the fact that you now said that this async relationship is then kind of the part that I was maybe the most scared of, is like, do we have like kind of ridiculous chains of async relationships into async relationships into async? So that, yeah, just a bit worried that how are we going to convert that into schema set, but yeah.
I think that that's a good question. I think that that's something where once you get into the schema world, like the first migration is get into the schema world. Preserve the existing behavior, but get into the schema world. Once you get into the schema world, you can migrate on a field by field basis. And so it's a lot easier to go in and chip away at that. It's not all or nothing. It's not whole resource. It's not whole app. It's go field by field and figure out, okay, what is this legacy field that I have? What's the behavior that's not going to be supported in the future? How do I get away from that? And that really brings me.
There was one more question.
We can,
If we have the time.
Yeah, we have the time.
On the request and await components, and then get request state and get promise state, right? Is there a fundamental difference? Because if I understand it correctly, get request state is WarpDrive specific then, and get promise state is more generic? Or are there like
That's
bigger
correct.
differences? Are there bigger differences between the two? Yeah, sorry.
All futures are promises, but not all promises are futures.
Yeah.
Right, so when you call store.request, you get back a future. It's quite literally an extended promise.
Okay. Yeah.
That promise, that future gives you access to things like abort, gives you the ability to call get stream, await get stream, and get the stream out of the response, out of the request handler. So if you wanted to do streaming responses that you could, it gives you direct access to the identity of the request. And all of those are things that the request component is then able to key in on and handle things like, okay, I'm going to do deduping. I'm going to do automatic invalidation. You use the loading block, and in the loading block, you put a spinner. In that spinner, you pass in like state.%complete. That %complete is actually just calling get stream. It lazily calls it, so you're not eagerly paying that cost. But when you use that property, it sets up the stream and it starts reading the response and literally gives you the %complete just for free. Like you'd have to do no work in your app. You can't do that with a regular promise, obviously. So that's the difference. Like we have one set of APIs that's just for general async, and one set that's very specifically for this enhanced promise behavior that you get with request.
All right. Okay. Thank you. That sounds nice.
Yeah. All right. So I suspect a lot of folks have been daunted by the idea of moving to WarpDrive because they see it as one single migration. It is, in fact, at least 3 migrations, maybe more. And this is because like what is WarpDrive is kind of like a wishy-washy thing, because again, WarpDrive is Ember data. So really what you're saying when you want to migrate to all the latest and greatest is all the different things that have changed over the past couple of years. I need to do the migration for that thing. So for instance, the 2 biggest ones are the migrating from the legacy request paradigms over to request manager. I see a lot of folks think that they have to do that first in order to migrate to schemas. These are completely unrelated. You can migrate to schemas first and still use all the legacy request infrastructure. Or you can migrate to only the latest, most modern request paradigm and still be using model. Literally doesn't matter. So if that was the thing that was holding you back, pick one, learn about it, start there. The second is really that migration from model to schemas. I think that there's been a kind of an eyeballing of Polaris mode, if you will, and going, ooh, like I would just want to go all the way there. And that's great. Like I want everybody to get to Polaris mode eventually when it is fully stable and polished and the thing that we want to recommend. But there's a ton in between those two states of I have models and I have schemas in Polaris mode. And the main thing is I have schemas in legacy mode. And legacy mode was the thing we built just for the migration path. It supports 100% of the things that you can do on a model. And that used to be true with some caveats. The caveat used to be, well, let's say I have a fat model. I've got methods on my model. I've got computed properties on my model. I've got getters on my model. I could figure out moving these things as this thing that you tell me is called a derivation. That seems really unwieldy. It seems like you're telling me to remove these things. What do I do? Am I stuck? And that's a good question. We added a new feature called extensions. The idea behind extensions, and you're going to love the name when you see it, it is Caution Mega Danger Zone Register Extension. And the name of the primitive that you're registering is literally Caution Mega Danger Zone Extension. Because the point is, this is not something you should rely on long term. This is something that you should adopt to get over to schemas and immediately start chipping away at. With extensions, it lets you take everything that you have in your model that's not something that you can easily put into your schema and just keep it. It's literally just like delete everything that was schema, and what you have left is the thing that you register as an extension. Very little work to do on that. So I have a helpful guide here that I literally wrote this afternoon. And because we publish every single commit, it's already published. So you can go there and look at it. Is it 100% done? No. Is it like 90% done? Yes. Again, I wrote it this afternoon. This guide is going to walk us through kind of step by step what it looks like to do a migration in what I think is the most beneficial way. This is not the only way to do this migration. This is a way to do the migration that I think gets you the most bang for your buck the quickest. Gets you onto the most recent version, gets you onto the ability to use the most recent stuff with the least amount of work in your app. So I'm just going to run through what this doc says. And then my intent is for the rest of this to literally just like help people. So if you want to pull out your laptop and literally try to do some migration stuff, or if you just have more specific questions of how do I do X, I want to answer those while I'm here. And we will just go as long as we want to with those. And when we're done, we'll go over to Wolf, was it? And have some food. So my recommendations, the first thing to do is actually migrate to native types. You should do this before attempting anything else. So if you are still on 4.x, we actually built a whole path for you to be able to migrate to the native types, even though the versions in 4.x didn't ship them. Every single package that we publishes a types-only version of itself. So all that we do here is we come in, step 1, delete all of the definitely typed types. Step 2, pick which tool you're using. This will change the command for you. Go here, hit copy paste, run that. It'll install all of the types packages. Notice how it says Ember Data Types at Ember Data Types/request. That's what I mean by we publish a types package. You have the package Ember Data Request. This Ember Data -types/request is literally just the types for that thing. And we're going to go all the way to Canary with it. I would recommend just going all the way to latest. Generally speaking, this is going to be a pretty smooth experience still. We are doing this at audit board with like a 4.12 roughly. So we have 4.12 in production. It's actually 4.13 Canary. I can talk to you about that if you care about Vite at some other time. But essentially we're running 412, but we're running with the latest canary types. The next thing that you're going to do is you're going to go into your tsconfig and you're going to make it understand where all those types are. Then you get to the hardest part of this. In the definitely types, there was these things called registries, a lot of APIs just kind of like, oh, I typed a model, I put it into the registry, and a whole bunch of stuff just kind of like magically picks up on it. The native types do not use registries. So a lot of reasons for that. There's a little guide in the docs here somewhere that tells you why. The high-level TLDR is it's really bad for TypeScript performance, and it just literally doesn't work with any app of any size. Like you hit like roughly 500 models, sometimes less. Congratulations, everything's an any. So registry, no good. Brands, pretty nice. And there's a lot of benefits to using brands in terms of flexibility with your types, because by treating the type as separate from the class, you're able to create types that are specific to say, I'm creating this thing right now, versus this is something I got from the server, versus this is something I got from the server and only has XYZ fields, or this is something I'm editing and I'm only allowed to edit XYZ fields. Today, if you only type the model class, all of those different scenarios have to be on one single type. And that's actually makes all of your TypeScript usage really annoying, because suddenly you're accounting for undefined and null everywhere, even when you really shouldn't have to. So brands come with a lot of things, and this is probably the biggest thing. So spend a whole bunch of time migrating to latest types. If you have a really motivated engineer, at Autoboard, we had a really motivated engineer. It was Peter Wagenet. He does a lot of open source stuff too. He just like spent 3 days and was just like, screw it. I'm migrating our 3 million line code base over to this, and did it. And yes, like huge code base in like 3 days. So it's definitely somebody who's highly motivated to do it and didn't even know that much about this strategy, just kind of roughly knew what I just told you, was able to do that in 3 days. So probably something you can figure out. Then we get to the migration. So step one, you're going to install the mirror packages. This is, I have no, oh, begin please. Okay. Let me, all right. Step one, install the mirror packages. I told you about the types packages. We have the same thing with the mirror packages. Every single package that we publish has a mirror package. The benefit of this is migrations. Literally, this just exists for migrations. Because like our applications in front end usually have the Highlander rule in play, where you really can only have one copy of a library and have it work. We just take every single package that we publish, rename it, point it to work at a completely other ecosystem of similarly renamed packages called the mirror packages. So if you are a Marvel fan and got the Mirrorverse, WarpDrive has its own Mirrorverse. Every single package has a mirror package. So when you want to upgrade it and you're, say, on 4.6 or you're on 4.12 and you're trying to get the latest, you don't have to uninstall the version that you're on. You just install the version that you want to go to in the other universe. So this command will install every package that you need for the Ember experience with maximum legacy support. You'll need to configure your build. If you're already using Vite, that looks like this. This should say like 5.0 or 4.12 probably. If you're not using Vite yet, you'll do this. Granted, this still shows Vite because I was just really into Vite. But even if this is like a classic build or embroidered Webpack, this is where you would do this configuration. You would make your export async. You would import setconfig. You'd run setconfig. You got to configure the reactivity for the mirror universe, even if you've already done it for 4.12 or some other thing. You still need to do this import. So at the top of your app file, you're just going to have this side effect import. You need to configure the store. If you are not using model fragments, that looks like this. Just literally copy paste it into, you'll notice I named it v2 store. So we're not going to override our existing store. We're just going to introduce a new store. fragments. You just set model fragments to true. And that will set up everything that you need for model fragments. That's already in Canary. And I guess I didn't actually set it false on the other one. So technically they're the same thing. As I said, I wrote these like an hour ago. And then step 5, convert and profit. So I have some links here to kind of the types of some key concepts that you'll probably want to explore and a couple of examples. So for instance, I'm going to make this in small end. Here we have a user model. We have already typed it in the new types, but it has a cache property, it has a computed property, and it has a method. We create a schema for it. We're going to use the defaults from legacy mode. This did not republish on me, or I did not refresh. I do think I pushed it. Let's see. Aha! Love this. So you're going to use with defaults from legacy mode. That just sets up all the things that are on model today as APIs that aren't things that you defined, like all the different methods, the state properties, all that kind of stuff. It's a resource schema for user. You had a first name attribute, you had a last name attribute, you had a best friend belongs to, you had a friends has many. And then we get into this interesting thing, object extensions, the user extension. We create a type. Forgot to add this to the type. There's one thing that's missing from this type, which is the extension portion of the type. But you write a type for your user, and if you want all of those state props and methods and everything to be in your type, you can use this with legacy type util to enhance the type that you write to have them all. And our extension. This is just literally the class that we had before, but we dropped extending from model. We dropped the parts that were schema, and we say, hey, actually, I'm a user extension. That's my name. This is the kind. I am an object. You can have array extensions too. That's how we brought back the array deprecated array like. And these are my features. And it's going to take that class and it's just going to use everything that's defined on the class as something that enhances your schema. You'll notice that we passed in object extensions as an array. Yes, you can extend more than one thing. So if your class is extending other classes or mix-ins, etc., like you write multiple extensions to represent those different concepts and just apply them in the order that you need. They will evaluate left to right when they merge down. Model with mix-ins as an example. So I have a user. User is extending timestamped. Timestamped has some adders. It's got a method on it. I'm going to come in with my schema for user. I'm going to say I have traits, timestamped, and object extensions, the timestamped extension. So this is another thing that we added to make going from a world with models and mix-ins over easier. So the corollary to a mix-in is a trait. Traits are just groups of fields, basically, that you can use to extend a schema. Traits can have their own traits. And there is a whole document outlining the tree traversal that happens as to how that flattens to become the list of fields that your thing actually has. Roughly speaking, if you ever learned the rules of mix-in application, hopefully you never had to, the trait application follows the mix-in application. So if you apply the traits, if you design your traits in the same way that your mix-ins were, so like if your mix-in had mix-ins, your trait has traits in the same order. If your model had mix-ins, your resource has traits in the same order. It should end up with all the fields being defined correctly, overriding each other correctly, the same way that you had it before. Still have our user type. This time I did just do like an extends timestamped. And our timestamp trait, name timestamped, mode legacy. Traits can have modes. in our case, everything that we care about right now is legacy. And fields that it had created at, deleted at, and updated at. And then I haven't given us the fragment example yet. I could fill that out while we're here if we are really curious. But basically, with fragments, there's a concept of object schemas, and so fragments are object schemas. And then fragment arrays are just fields that point at an object schema. And then because fragment arrays had fragment-specific behaviors and fragments had fragment-specific behaviors, there is an extension for that field and an extension for fragments, an object extension for fragments, an array extension for the array field that takes care of ensuring that all those same fragment APIs are there. So again, 100% of the API surface is supposed to be there for you on the other side of this. So then post-migration, you drop the old packages, you drop the config for the old packages, you delete your store service, you rename your VT store over to store, you rename WarpDrive mirror back to WarpDrive, and you're done. You have gone from A to B. This right here is a really good thing to be able to set up to basically feature flag. Like this whole thing is designed where you could go do this in a non-long-lived branch and feature flag your way from A to B, testing it out as you go. So a lot of flexibility here in this, even though it like may seem overwhelming right now. Sit with it, and you may come to see that. So that's the way that I would go about doing this migration. You'll notice that I didn't say anything about how do I get over to Request Manager. I didn't say anything about how do I get from legacy model to Polaris mode. I think those are really important topics. I'm happy to help answer questions on that now if you really want. But I think just literally getting onto latest has a ton of value even before you consider those things. One of the things you may not realize is that things that are in Polaris mode, things that are in legacy mode and models can all interop at the same time. As long as all things of that particular type are now using the thing that it is. So like I could have a user model, a pet resource in legacy mode, and say a car resource in Polaris mode. The relationships between them will just work. You don't have to like have one store that's all Polaris mode, one store that's all legacy mode, one store that's all model. And if you use the utility for setting up that legacy store experience that we show in this, it comes pre-configured with the ability to do that. So if you still have models in your app, it'll just use the models. The main reason to go ahead and move over to schemas when you're jumping from 4.x to 5.x is models don't have the deprecated behaviors anymore in 5.x. Everything that we deprecated went away, and there's not always a path to bring it back. Like we're trying very hard to bring stuff back in a way that you could opt into it from legacy, but not everything could be. But everything could be brought back as a schema. So otherwise, I would just say literally just bump to 5.x and then start rewriting one at a time. Keep your models. Especially if you're a model fragments user, there's just like no chance you're getting beyond 4.6 without doing a jump like this. But here's the really awesome news. We've been working on a code mod. Takes all your mixins and all your models and generates a type, a schema, the various traits you need, the various extensions you need, helps you wire those together automatically into the store. So there's a very real chance that if you go and you do the first part of this, migrate to the native types, you do the configuration part of this, let's just get the infrastructure in place, that in the coming weeks, you'll be able to run a code mod and just overnight update yourself and see if it works. And again, if anything doesn't work, please open a ticket, because our goal is that 100% of what we deprecated and removed in 4.x is able to be brought back. I don't want to leave anybody behind at this time. So yeah. Any questions? Anything anyone wants me to dive in on?
Yep. We have a question on the stream. I say we have a big 3.x app that we are currently migrating to 4.x and beyond. We don't plan to go for TypeScript right now. Thus, migrating to WarpDrive is still somehow achievable.
So on 3.x,
Yeah.
and with TypeScript or without TypeScript?
I suppose without TypeScript,
Without
because
TypeScript.
they don't plan to go for TypeScript.
The answer is yes, because all of the newer packages and all of the mirror packages just don't exist in 3.x. So you can install the new experience and have both in your app at the same time. The code mod might even work for you for a 3.x app. There wasn't that much that got deprecated in 3.x, between 3.x and 4.x from the data perspective. Almost everyone I know that's been stuck on 3.2.8 is stuck there because they just decided to lock their data version to their Ember version, not because data itself was their blocker. So I say that this is the 4.x to 5.x migration. Probably this works for 3.x too. And even if it doesn't, the two-store migration approach will.
But even without adopting TypeScript,
Even without the TypeScript setup.
Okay.
The reason to start with the TypeScript migration is only if you're already using TypeScript. Because if you're already using TypeScript, you have the definitely typed types in your project. You are going to, like, shit is going to hit the fan when you install this stuff. You really do have to move to the native types. I feel like I saw hands over here, different places. No. I do heavily recommend that you begin typing things with WarpDrive, because you will get a lot more value out of it if you do. A core philosophy that I have is that even if you don't feel that it's a good idea to type all of your product code, you should type your core code. The stuff that everybody on your app is going to be using a lot of. Like that's going to provide the most value. And your data is everywhere in your app. Having that be typed is a huge advantage. So
I'm a plant. Can you talk more about running two stores at the same time? Do they share a cache? And if not, what do I do about that?
So there are two ways to answer this question. There is the, can I run two stores from the same version? And then there is the, I'm running two stores from different versions. When you're running two stores from different versions, absolutely everything is just completely separated. And sharing of things is perhaps a little dangerous, because say you wanted to write a schema or some such that was working in one version, it may not work in the other version, right? The features available to each might not be exactly the same, and so it's probably best to have fully separated worlds there. But let's say that somehow you got everything onto the same version and you just wanted to have two stores. WarpDrive supports you having as many stores as you want. Like, the only reason folks have had just a single store historically is because we provided one as a service, and that was pretty useful. But it is literally a class that you can instantiate with the new keyword, and you can create as many of them as you want. You can create multiple services with them if you want. You can use something like one of the context add-ons and have a unique store per context if that's what you wanted. Now, in terms of sharing data in between, you can't. Like, that is by design. Like, the data in one, it has its own cache. It's not shareable in between. If you decide that you really wanted to, you would need to serialize state out of one of the stores and push it into the other store. And there are different APIs in the cache that can help you with that and do that pretty quick. That's maybe not as hard as it seems, but you would have to like manually sync between. It's intended to be isolated.
Are you planning to add any tools to aid the making of schemas? Like, for example, you can define a field twice and it won't get noticed by your IDE, or you can have a mismatch between the types and then the real fields defined on the schema. What are the plans for that?
Yes, similar to the payload validator that I showed earlier today, I want to add a schema validator that has the same like pretty print JSON and fuzzy matching of what you probably did wrong to tell you what you should probably do instead. I think that there's a ton of stuff that we can very easily and trivially do that way. You might say, well, why not just do it with something like Valibot or Zod? But if you do it with something like Valibot or Zod, like you get more often than not a really obtuse path error on an object that you're not sure what it is. Plus you incur the runtime cost. Whereas what we're doing with the JSON parse, AST parse is something that completely goes away in production. So yes, we can do more there. I feel like there was maybe 2 parts to that question and I answered one. So that's just like, it's just a hard problem, period, right? Like if you generate the type from the schema, you get right back into the same problem that you have with models where you really only have one type to represent multiple things. And that's not actually a fun world to be in. Like it doesn't actually make your data useful to use. I do think that we need to improve the ergonomics there a lot though, both for generation of schema and generation of types. Where I see that going over time is the introduction of tools that do stuff like, I have open API specs, give me like some base types and a base schema from that. Or I used Postgre as my database. I have a schema for it, and I perfectly expose all of those types via my API, maybe dangerously. Generate me types and schemas from that. Or I use GraphQL. Generate me a type and a schema from the request that I'm making or from my federated schema. There's a lot of different tools that we can put in place to generate artifacts to help you. We do have a couple things to help you ensure that 2 types are compatible. So with WarpDrive, with the newer stuff, we make it pretty easy to have partial fields. So like you have a user and in one context you load first name and last name. In another context, you load first name, last name, and title. You write a separate type for each to represent what you have in those contexts. How do you make sure that both of those are actually types that represent a like mythical 100% everything it could possibly be type that you might have? TypeScript doesn't make this intuitive, but it does make it possible to do fairly easily. If you have user with first name and last name, and your main type is first name, last name, and title, you can't say does first name and last name extend first name, last name, and title. It obviously does not. It's missing a field. It will give you a type error. But you can say does first name, last name, title extend first name and last name. You flip it around. So we have a type util that just literally does that for you. It just flips it around and says, does TypeScript say that this thing satisfies this thing in reverse? So you can come in, you can write a base type that is the maximum thing that your API might give you for that resource. And then you can write more specific types and quickly validate them against it to make sure that they stay in sync. And if they are ever not in sync, that they'll get validated against it. Something that is a common theme in our TypeScript story, like I think people are going to have a lot of questions about it over time because there's a temptation to say, can't you do more for me? Like it just seems like you gave me some generics and a couple of utils and like you left the universe open. The answer is that that's very much by design. Like, if you look at what happens with Zod or Valibot or backend ORMs like Prisma, they all end up with really bad TypeScript performance, or they end up in a place where they have to do type compilation to give you decent TypeScript performance. Basically, they box you into very specific ways of thinking about your types that are probably not right for your app. If we were to make a decision it might make 10 of you happy and 100 of you mad. So instead, we did something that was maximally flexible with an easy ability to put a validation layer of your own over the top for both the schemas and the types. Cool. I don't see any more hands. Do we have any? Oh, you have.
Yeah. So this new migration, right, is great, and it answers a lot of the questions. It gets you over the line, like it gets you into the WarpDrive world, let's say, but there's still a ton of things which are deprecated in the new world, in the new WarpDrive way. Do you have, like, how would you prioritize addressing those issues?
I think some of the things you need to get off of faster than other things. So I would say the stuff to prioritize is anything that Ember itself is looking at deprecating. So if Ember is deprecating mixins, get rid of mixins. If Ember is deprecating computed in the classic object model, get rid of computed in the classic object model. Because at the end of the day, we can try to keep stuff around in legacy, but we can only actually keep it around as long as Ember as a framework supports it. So I would start there. Like start by prioritizing what's stuff that's going away from Ember itself. Then come back and look at it and say, what are the things that idiomatically is stuff that WarpDrive is really trying to tell me I shouldn't do? Async relationships is one of those. It's probably the biggest one of those. It's probably the hardest one to migrate off of. We've put quite a bit into utils like getPromiseState and await for that reason. It's still not good enough. I think we need to do more. But I think the more is the Polaris mode relationships. I think people are like, well, this is bad, but like everything else that I'm looking at is also bad. And that's because the replacement isn't actually there yet. The replacement for an asynchronous relationship is an object with a slightly different shape. And that object with a slightly different shape has synchronous access to its data. So all of your computed properties and cached getters, all of that derivation you were doing off a state that you will eventually load and will eventually be there would still be possible. You'd have to change some of the paths, you'd have to refactor a little bit, but it's still possible. And right now, today, it doesn't feel like it's possible. And so I think that's where people get stuck. There are some tricks for today where you can still like, okay, I'm going to get off of async relationships and do the synchronous data resolution. Like you can use the references API. That's also part of legacy, but it's a part of legacy that is a lot easier for us to keep around. And it's much more similar to the paradigm that we're moving to. If you've never seen that, on a model you can call belongs to, and I don't mean the decorator belongs to, on a model you can call belongs to, give it the name of a relationship on your model. That gives you a reference back, gives you synchronous access to its value, synchronous access to methods like reload or load to kind of manually work with that relationship. That is a less ergonomic, but like more in principle aligned way of working with the data to where the relationships are going.
What about other stuff like transforms would be another thing that's probably, and maybe not even officially deprecated, just as I think async relationships are not officially deprecated.
Yeah. Transforms are definitely the worst part in my mind of models. Like if there's one thing in the legacy world that is nothing to do with Ember and everything to do with Ember data that just you should get off of, it's that. The good news is it's also one of the easier things to get off of. So in the old world, you have transforms. When you have this field kind of attribute, if you give it a type, that's the name of the transform. In legacy, attribute is a legacy, what we call legacy field. The Polaris equivalent to it is just called field. And type on a field or generic field is what we call transformation. Transform, transformation. Sorry, naming is hard. Transforms are a serializer concern. What that means is that like nothing the model ever did used that transform. What would happen is your serializer would come in and say, oh, it looks like I'm transforming a user right now. I'm going to look up its schema. Oh, I see that it has an attribute here. I'm going to look up the transform for this attribute, and I'm going to run it on the value I just got from the API. Or if you were saving, it would do that in reverse. But it was the serializer doing it, which meant that let's say you had a number coming from your API, you converted it into a date, and then you called create record. Well, what do you pass to create record? Do you pass a date or do you pass a number? Who remembers? Or you are converting it to a number, but then you pass it into a form input, which casts it right back to a string on you. Now you have a data type issue in your app and it leaks and it gets everywhere and it's really frustrating. Transforms just weren't good. And they ran at the wrong layer of the abstraction. And they even caused issues with just the concept of serializing the cache and having it in a good state where you can trust it. Because if I were to have a transform that produces a date, well, I can go directly manipulate that date. Nothing about it's reactive. The cache is going to have no idea that I changed it. There's no comparison API for it. So you just changed the cache state and nothing knows. So has dirty attribute says, oh, false. You didn't change anything. You're good. Transformations flip the switch. Transformations are something that the record takes care of. The reactive resource takes care of. So the data in your cache is whatever came from the API, period. That's it. The reactive resource that looks at the schema and says, okay, you just accessed first name. I have a transformation called string, or maybe double the name up for some reason. Okay, I'm going to take the raw value out of the cache. I'm going to turn it into the new value for the UI. And then when you go in and you set a value from the UI for first name and you mutate it to something else, it says, okay, well, I'm going to go get the transformation. I'm going to run it in reverse. And now the value in the cache is what you would want your API to have given you. So the cache is always trustworthy. The UI is always accurate. You don't have any of these impedance mismatches. So that most of the time, moving from a transform to a transformation just fixes bugs. Like, that's literally all it does for you, just fix bugs, which is great. The downside is serializers. If you do that move before you kill off your use of serializers, you're probably going to stop serializing that field. Because in order to maximize compatibility, we had to do a couple of naughty things. Serializers will only iterate the original 3 legacy fields. Attribute, belongs to, and has many. Nothing else exists for them. So you might ask, if you've intuited enough of the system, how is model fragments going to work? Because model fragments is using only new field types. And model fragments is actually kind of heavily reliant on serializers. And the answer is when you put model fragments true in that, you actually override how the serializers work and push all of the other fields into them too. In a way that model fragments is going to understand what's going on, but is riskier. Like it'll get you through the migration. Like it's not a good paradigm. Yeah.
Does all of this work for like APIs that don't support the JSON API spec? Because I see a lot of the docs are like really for JSON API.
Not 100% sure I fully understood your question.
So we have an API that doesn't follow the JSON API spec. Does all of this work for that as well?
That's a good question. The reason the JSON API cache is in its own package is it still has semantics that are specific to the JSON API spec. And so it still expects you to give it data that it can interpret from the perspective of that spec. What would happen if we didn't want to do that? We'd have our own spec. And it still wouldn't be what your API has. We have to choose a spec at some point in order to understand the structure of your data. The JSON API standard does a lot of things right, that other standards don't do well. So it's been really useful to kind of piggyback on that for the couple of things that we've really needed for. But I think longer term, we don't need it. As we have built out to newer primitives in WarpDrive, the more that you kind of clean up the craft and the more that you see what it is that you've built and have, sometimes the more you realize, oh, I could do this or I could do that. And in the process of that, it became kind of clear that we could introduce document schema. And document schema is basically just very similar to resource schema, except there's only 4 field kinds. I'm a meta field, I'm a links field, I'm a primary data field, or I'm an included secondary data field. And instead of needing the JSON API document structure to understand the response that you gave us in order to know where to find your resources, we would just use that. We already have the concept of your schema declaring individual source keys to say, hey, you gave me first -name -rised, and I want to display first name in camel case. We already have that transformation built into resource schema. So the only thing left, if we introduce document schema, is relationships. Understanding what data is a relationship in a resource is hard if you don't have a really nice spec like JSON API. Most of the time, it means that you have to look at and keep in sync 2 different fields. Sometimes it means you only have 1 field and you have to parse a string into 2 parts to understand the difference between its type and its ID. Sometimes it's 2 fields. Sometimes it's like 1.5 fields. Because you have like a has many and you have an array of IDs, but you only have a single type. What do you do for polymorphism in that case? Like there's no way to represent polymorphism in that case. So JSON API has been really, really useful for those cases. But what if instead of making the assumption that JSON API makes of where relationships live and how to extract it, what if instead we gave you a hook that just said, for this given field, please extract type and ID. For this given field in your schema, please update type and ID. And it was up to you to determine how to interpret that. If we did that and we had document schema, there is nothing left that is JSON API specific in the cache. At which point the cache just becomes part of core. It's no longer a separate package. You still would probably want to do some configuration of it. If you, not all the time, like we could hide that configuration of it most of the time. And then when you needed to provide those hooks, you would. But yeah, stuff just gets simpler. I think even a year ago, it wasn't as clear that we could do that. But as the layers have come off, as the cruft has come off, it's gotten clearer and clearer. Hey, we could actually double down on the idea of schema, and we could do this. I think it's time to go to Wolf.
All right. Thank you very much.